Namaskar and welcome to this special lecture in our course on hydration, porosity and strength of cementitious materials. And today we will be discussing the assignment 1 in the course, which is based on the lectures that were given in the first week. The questions that have been uploaded and given to you are the MCQ type, where there are two statements given and you are supposed to identify whether both the statements are true, both the statements are false, A is true, B is false, or A is false, B is true, and so on. I understand that though the questions are based on the material covered, you might find it difficult to answer those questions only on the basis of the material covered. The expectation was that based on the questions or on seeing those questions, some of you at least will go to some of the reference material and try to learn a little bit more. So to supplement that exercise and go over the questions with you, I thought we will go over the questions in this lecture and let you know what the interpretation we had for the different questions. So now let's look at the first question, which said slump is a measure of the workability of concrete. This is obviously true, and workability of the concrete is also an indirect measure of its strength, which is false. Workability is a property of fresh concrete and, as we will learn later on, is related primarily to the water content in the mix. Strength, on the other hand, is related to the water cement ratio, and there is no direct relationship between workability and strength. Therefore, the first statement is true and the second is false. Going to the next question, the first statement is increase in the air content in concrete decreases its workability. No, if we increase air in the concrete, the workability increases. That's because the ball bearing action of the entrained air particles, which facilitates movement of material, reduces the friction within the constituent materials of concrete. Now when it comes to statement B, air entrainment is recommended for concrete to be used in an environment where cyclic freezing and thawing of pore water is expected. This statement is true because we showed, without getting into the mechanism of how air content helped in increasing the durability of concrete in that environment, we showed a graphical representation of how it has been found that entrained air concrete performs better in freezing and thawing environment compared to non-air entrained concrete using the concept of durability factor. Coming to the third question, which said that the strength of concrete increases if the water cement ratio is increased, this answer or this statement is actually false, because as the water cement ratio increases, the free water available beyond the amount of water which is used for hydration increases, the porosity also increases, and therefore the strength goes down. So which actually relates to the part B of the question, which says porosity in concrete increases if the water cement ratio is decreased. So please be careful when you read these statements. Here it increases when this is increased, here it is increases if it is decreased. So you have to be careful when you read these questions and look at each of them very carefully. So in this particular case, statement B and A are both false. Coming to the next question, fly ash is mixed with other raw materials during blending before heating during the manufacture of cement. The key word here is before heating. Fly ash is not added to the constituents of the cement and is not part of the clinker. The clinker is what is formed at the end of the heating process, and then when the clinker is being ground, at that stage we add fly ash. That is the normal process of manufacture of fly ash based cements or pozzolanic cements containing fly ash. Gypsum is added during the manufacture of cement principally to regulate the setting time of eliminates in the cement, that statement is true. So in this case, statement A is false and B is true. So now as question number 5 is concerned, concrete used in rigid pavement construction is high workability concrete, and concrete used in foundations having a heavy reinforcement should be stiff. Now there is no hard and fast rule or no law which governs what kind of concrete should be used. It's only a matter of practice, and it's also a matter of application and the functional requirement. As far as rigid pavement construction is concerned, most of the time we are dealing with plain concrete. It's not reinforced concrete, and there's no reinforcement in it. Therefore, it's much easier to compact the concrete using devices such as rollers. Therefore, the old dictum that in principle the concrete should have the minimum workability required for a particular application, that shows that in rigid pavement construction we can make do with stiff concretes, and that's why the first statement is false. Whereas in the second case, because of the heavy reinforcement, it's difficult to compact the concrete using internal vibrators and so on, and therefore one would like to use high workability concrete, and therefore the concrete should not be stiff. Therefore, both these statements are false. As far as this question is concerned, the classification of concrete based on RCPT is based on amperes. This is false because you will recall that the table which I showed you for interpretation of results, it is based not on amperes but on coulombs. Of course, when we carry out this test, we do not measure the coulombs. What we measure is the current that is passing at any given point in time, and we integrate this current over the period of time that we have to get the coulombs. But the final interpretation is in terms of coulombs, and therefore a statement that classification is based on amperes is not really true. The durability factor for concrete is estimated for concretes likely to be exposed to alkali aggregate reactions. The answer is false because the durability factor is used for concretes in the case of cyclic freezing and thawing. In this question, let's consider the statement: the sources of alkalis in concrete in the context of AAR is cement. This statement is true because the alkalis that we are talking about are the sodium and potassium ions which are present as impurities in the cement, and they react with the reactive aggregates. And these, if you look at the composition of cement, are listed at the bottom with Na2O and K2O content, which is finally expressed as an equivalent Na2O content, and that's how we evaluate the alkali content of cement. Expansion on account of AAR is attributed to absorption of water by the reaction products of alkali and reactive silica. This statement is true. So question number 8, the formation of the ITZ around the coarse aggregate in concrete is a manifestation of bleeding in concrete. This statement is true. The paste in the ITZ is characterized by a slightly lower water cement ratio than the paste elsewhere. This statement is false because it's not a slightly lower water cement ratio that we are concerned about. It is that the water cement ratio in the ITZ is actually slightly higher because of the bleeding and accumulation of water around the coarse aggregates. So when we go to question 9, the quantity of C3S and C2S is the highest and lowest than that of other compounds respectively. This is false, and this is based on facts. You can actually look at those numbers given in the lecture and you will find that this statement is not true. Oxides of silica and alumina are present in minor amounts. This statement also is false, and you need to go back to just the data which is presented to you in the lectures or in the reference material. With regard to specifications or the Indian standard specifications for grades 33, 43 and 53 of cement used in India, the initial and the initial setting time for the 3 grades of cement should be lower than 30 minutes. Here also the catch is lower than 30 minutes. For all cements, the initial setting time is required to be more than 30 minutes, and that minimum setting time being fixed at 30 minutes is given from the point of view that we need a certain amount of time after addition of water so that the concrete can be transported to site and placed. So the designation of strengths are based on compressive strength at 28 days. Yes, this statement is true. So here the first statement is false and the second is true. Gypsum is added to control the quick reactivity of C3A, and the normal dosage of gypsum is in the range of 4 to 6%. Both these statements are true, and you just have to go back to see the lecture a little more carefully. Now in this case, if we look at the two statements, unsoundness of Portland cement is said to exist if the free lime or free CaO content is less than 0.8%, and the unsoundness of Portland cement does not exist if the MgO content is greater than 6%. Here again both these statements are false, not because there is a problem with the numbers, but because of the signs. You have to be careful with the sign here and the fact that in this statement we are talking of does not exist if the MgO content is greater than 6%. So if you are careful with reading the question, there will be no issue with arriving at the right answer. Both these statements are false. So now if we look at this set of statements, slow cooling of clinker is recommended to increase its reactivity, and the temperature range in the cooling zone is 1450 degrees to 25 degrees centigrade. The second statement is true, but the first statement is false. Please recall that if the clinker is allowed to cool at a slower rate, it will increase the size of the crystals and so on, which will actually contribute to reducing the reactivity of the cement. Therefore, there is a rapid cooling that is recommended in order that the reactivity is increased. Again, relating to the production of cement, wet process is preferred over the dry process due to lower energy consumption and production cost. This statement is false. The second statement, that aluminates and belite are the last compounds formed in the kiln, this too is false. The second one is based purely on the facts, and the first one is based on the understanding of the process that the wet process requires us to evaporate a lot of water which is present in the raw materials during the drying stage. So that makes it energy intensive. So coming to question 15, limestone gets converted to CaO in the cancellation zone in the kiln, and alites gets converted to belite in the clinkering zone of the kiln. Both these statements are explicitly covered in the lecture that was there, and you would know that the first statement is true and the second one is false. The grey color of cement is due to the iron content in the raw materials, and the Blaine's apparatus is used to determine the fineness of cement. Both these statements are true. The Blaine's apparatus actually works on the principle of permeability of air through a packed bed of materials. So what is done in that is that we take a certain quantity of cement, pack it in this small container, and have a certain volume of air pass through this. Now as the fineness of this material here increases, the time it takes for the fixed volume of air to pass through increases. So as the time increases, the fineness also increases. So that is the principle of the Blaine's apparatus, and we use cement powder here, pass the air through this and determine the time, calibrate this apparatus with a powder of known fineness, and that is how we calculate the fineness of cement, which is expressed in terms of meters square per kilogram. So, the question number 17 deals with significant amount of carbon dioxide is evolved in the clinkering zone, and C3S is the last compound that is formed in the cancellation zone. Both these statements are false. And coming to this question, the temperature in the clinkering zone is 900 degrees to 1350 degrees, that is false, and the temperature in the dehydration zone is lower than 600 degrees, this statement is true. So, these are questions which are based on the facts that are already presented to you in the lecture, and I do not think you should have a difficulty in answering them. With this, we come to an end of the questions that were part of your first assignment, and I hope that with this explanation you are able to understand whatever mistakes you made in answering them, and therefore we look forward to more participation from you as we go along in this course. Thank you.